If you add any two complex numbers, you are going to get one more complex number. If you subtract any two complex number, you are going to get a complex number. So addition and subtraction of a complex number is again a complex number. Any number of the form a plus ib is called a complex number, where a and b are real numbers and I is equal to root of minus 1 is an imaginary number. In algebra of complex numbers, we are going to study regarding addition of complex numbers, subtraction of complex number, multiplication and division of a complex number. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session, I am going to discuss regarding very important and the simple concept, that is regarding complex numbers. So in this session, I am going to discuss regarding the definition of a complex number and the operations on complex numbers like addition, subtraction, multiplication and the division of a complex numbers. Now, before going to the exact operation, let us know what is the definition of a complex number. What is a complex number? Now, a number of the form a plus ib, any number of the form a plus ib is called a complex number, where a and b belongs to real numbers. A and b are any real numbers. Then the set of real numbers a and b belongs to the set of real numbers, and I is equal to root of minus 1 is called a complex number. So I is equal to root of minus 1, an imaginary number, iota, that is a number of the form a plus ib is called a complex number, where a and b are real numbers, set of real numbers, and I is equal to root of minus 1 is an imaginary number. So where a is called the real part and b is called the imaginary part of a complex number. This is called the real part of a complex number and this is called the imaginary part of a complex number. So the set of complex numbers is denoted as C. C is the set of complex numbers and is given by x plus iy, such that x and y belongs to real numbers and I is equal to root of minus 1 is an imaginary number. I is equal to root of minus 1 is an imaginary number. So any number of the form x plus iy is called a complex number, where x and y are real numbers and I is equal to root of minus 1 is an imaginary number. So in a complex number x plus iy, this is a complex number. This x is called the real part and y is called the imaginary part of a complex number. So if a plus ib is a complex number, a is called the real part and the coefficient of I, that is b, is the imaginary part of a complex number. So usually the set of complex numbers is denoted as C is equal to x plus iy, such that xy belongs to R and I is equal to root of minus 1. I is equal to root of minus 1. Let us take for example 1 plus 6i is an example for a complex number. Root 3 plus I is also an example for a complex number. 1 minus 2i is also an example for a complex number. Few more examples for complex numbers are, I can write 1 plus I into root 2 is also an example for a complex number, or even minus 1 minus I root 2 is also an example for a complex number, or another complex number 1 by 2 plus I into root 3 by 2. This is also a complex number. And even we can write any number in the form of a complex number. 0 plus 3i is a complex number and 4 plus 0i is also a complex number. So these are all examples for complex number. So in this complex number 1 plus 6i, 1 is called the real part and 6 is called the imaginary part. Whereas in this complex number 1 minus 2i, 1 is the real part and minus 2 is the imaginary part of a complex number. Let me take one example. 1 by 2 plus I into root 3 by 2 is a complex number. Here in this complex number, the real part is 1 by 2 and the imaginary part is root 3 by 2. So this is real part and the imaginary part of a complex number. So any number can be expressed as a complex number, right, with the real part and the imaginary part. Now another example for a complex number, that is a complex number is of the form a plus ib is a complex number. Another example for a complex number is, that is 1 plus root 3i is also a complex number. Here 1 is called the real part and root 3 is called as the imaginary part. Suppose if I write minus 1 minus I root 3 is a complex number, here minus 1 is the real part and minus root 3 is the imaginary part. Imaginary part is minus root 3. So real part is minus 1 and imaginary part is minus root 3. Okay. This is regarding the complex number. So any number of the form a plus ib is called as a complex number. So any number of the form a plus ib is called a complex number, where a and b are real numbers and I is equal to root of minus 1 is an imaginary number. Now, let us come to the algebra of complex numbers. So, in algebra of complex numbers, we are going to study regarding addition of complex numbers, subtraction of complex number, multiplication and division of a complex number. Now, let us know regarding addition, subtraction of a two complex number. Now, let us consider two complex number. Now, by the definition of a complex number, z is equal to a plus ib. Z is equal to a plus ib is a complex number, or we can also write z is equal to x plus iy is a complex number. Let us consider such two complex numbers. Z1 is equal to a plus ib and z2 is equal to c plus id. Let z1 and z2 are two complex numbers where z1 is equal to a plus ib and z2 is equal to c plus id are two complex numbers. Then let us take the addition first, the addition of complex numbers. First one, addition of complex numbers z1 plus z2. Now what is z1? A plus ib plus z2 is c plus id is a complex number. Let us add the real part first. Real part is a plus c plus imaginary part ib plus I into d. You can take I common factor. This is equal to a plus c plus I into b plus d is of the form x plus iy. So this is again a complex number. X plus iy, this is a complex number. See, just add the real part and imaginary part, express it in the form of x plus iy and observe it is of a form x plus iy, then it is called a complex number. Now, whereas on the subtraction, z1 minus z2, let us take z1 minus z2. What is z1? A plus ib minus z2 is c plus id. Subtract this, just a plus ib as it is, minus c minus d, real parts and imaginary parts, a minus c plus I into b minus d. Again, this is also of the form x plus I into y. What is x here? X is nothing but capital X is equal to a minus c. Capital Y is equal to b minus d. Here x is equal to a plus c, y is equal to b plus c, b plus d. So here x is a minus c and y is equal to b minus d. Therefore, again this is of a form x plus iy. So that means, what is the conclusion? If you add any two complex numbers, you are going to get one more complex number. If you subtract any two complex number, you are going to get a complex number. So addition and subtraction of a complex number is again a complex number. That's it. Okay. As usual addition, just add real part and imaginary part separately. Now let us take an example. Let us consider z is equal to 4 plus 5i and z is equal to 1 plus 7i. Let us add these two, z1 plus z2. 4 plus 5i plus 1 plus, so let us add this z1 plus z2, z1 plus z2. What is z1? 4 plus 5i plus z2, z2 is equal to 1 plus 7y. Let us add real part. What are the real parts? 4 plus 1 plus imaginary parts I into 5 plus 7. So what is 4 plus 1? 4 plus 1 is 5. 7 plus 5 is equal to 12. So 5 plus 12i is a complex number. Now if you subtract these two complex numbers, z1 minus z2. So z1, z2 is nothing but 4 minus 1 is 3 and so this is 4 minus 1 plus I into 5 minus 7. 5 minus 7 is minus 2. Plus into minus minus. So this is nothing but 3 minus 2. I'll write here z1 minus z2. What is z1? Z1 is 4 plus 5i minus z2. Z2 is 1 plus 7i. Just multiply by negative sign. So this is 4 plus 5i minus 1 minus 7i. Just equate the real parts. What are the real parts? 4 minus 1 plus 5i, 5 minus 7 into I. So this is equal to 4 minus 1 is 3, 7 is minus 2, this is minus 2i. So 3 minus 2i is the subtraction. So again this is a complex number. So what is the conclusion? Addition and subtraction of a complex number is again a complex number. So just add the real parts and imaginary parts separately, or subtract the real and imaginary parts separately, you will get the answer. That's it. Okay. Now let us take the multiplication of two complex numbers. Now same as usual, let us consider the two complex numbers z1 and z2. z1 is equal to a plus ib and z2 is equal to c plus id. Where are the two complex numbers? Then the multiplication of these two complex numbers is z1 into z2 is equal to a plus ib into c plus id. Just ordinary multiplication. Multiply this a into c minus b into d plus I into a into d plus b into c. See, I will show the ordinary multiplication, as usual multiplication for this. A plus I into b into c plus I into d. Let us multiply. A into c is ac plus a into I, a into d into I, again plus I into b into c is bc into I, again plus I into I is I square b into d. Since we know I is equal to root of minus 1, I square is equal to minus 1. So this is equal to a into c. Now I square is minus 1, this is minus b into d. Let us group the real terms and imaginary parts. Just you can take the common factor. What is left is ad plus bc into I. So see here, AC minus BD plus AD plus BC into I. So just multiply it, you will get the answer. That's it. This is called the multiplication of a complex number. So again, this is of the form x plus iy, a complex number. So multiplication of a complex number is again a complex number. Hope you followed. This is the general method. Let me take an example. Okay. Now just take this example, 2 plus 3i into 4 plus 3i. So just multiply these two first. So that is nothing but 4 into 2 is 8 minus 3 into 3 is 9. 8 minus 9. 8 minus 9 is minus 1 plus I into AD into BC. AD into BC. AD into BC. These two. So 2 into 3 is 6 plus 3 into 4 is 12. That's equal to 18i. Or the very easiest method, just ordinary multiplication. Let us multiply this. 2 plus 3i into 4 plus 3i. So 2 plus 3 into 4 plus 3. Just multiply this. 2 into 4 is 8 plus 2 into 3 is 6i. Again, from this 3 4s are 12i plus 3 3s are 9i square. Since I is equal to root of minus 1, I square is equal to minus 1. So this is 8 plus 6 plus 12 is 18i. Add this and I square is equal to minus 1. This becomes minus 9. So 8 minus 9 is minus 1 plus 18 times I. That's it. Minus 1 plus 18i is again a complex number. Minus 1 plus 18i. That's it. This is the method to multiply a complex number. So if you multiply a complex number, you are going to get again a complex number. This is same. Addition and subtraction is same as that of the ordinary algebraic addition, where you are going to add real part and imaginary part separately. Here also same as that of multiplication, that is multiplication of linear equations. Just multiply and equate the terms containing real and imaginary separately. That's it. Now let us come to the next one, is the conjugate of a complex number. Now what is the conjugate of a complex number? If z is equal to a plus ib is a complex number, then z bar or 1 by z is equal to a minus ib is called the conjugate of complex number, and it is denoted as z bar. If z is equal to a plus ib is a complex number, then the conjugate of this is denoted as z bar is equal to a minus ib and vice versa. So this z and z bar, that is a plus ib into a minus ib, will form a conjugate pair. This is called the conjugate pair of a complex number. Now suppose if a minus ib is a complex number, then a plus ib is called the conjugate. Okay, so just change the sign for imaginary part. That's it. So suppose if x plus iy is a complex number, then the conjugate of this is x minus iy. That's all. These two are called as the conjugate pair. So if x plus iy is a complex number, then change the sign for imaginary number, that is x minus iy is called the conjugate of the complex number. If z is a complex number, then the conjugate is denoted as z bar. Now let us take an example. Suppose if z is equal to 2 plus 3i is a complex number, then z bar is equal to 2 minus 3i. So 2 minus 3i is the conjugate of 2 plus 3i. Similarly, if z is equal to minus 5 plus 4i, then the z bar is minus 5 as it is, and the change for plus 4i becomes minus 4i. So minus 5 minus 4i is the conjugate. Suppose if this is a complex number, if 1 by 2 plus i into root 3 by 2 is a complex number, then the conjugate of this is denoted as z bar is equal to 1 by 2 minus I into root 3 by 2. Similarly, suppose if this is the complex numbers, minus 1 by 2 minus I into root 3 by 2 is a complex number, then the conjugate for this is, the real part will remain the same, minus 1 by 2 as it is. Just we are going to change the sign for this imaginary part. Minus becomes plus I root 3 by 2. This is called the conjugate. So, if minus 1 by 2 minus I root 3 by 2 is a complex number, then minus 1 by 2 plus I into root 3 by 2 is the conjugate for this complex number. So, just changing the sign for an imaginary part will give the conjugate. That's it. Now, let us come to the division of a complex number by a non-zero complex number. So, division of a complex number by a non-zero complex number. Now, let us consider two complex numbers z1 and z2, where z1 is equal to a plus ib and z2 is equal to c plus id. With a two complex number, then z1 plus z2 is equal to a plus ib divided by c plus id. Now, how to divide? So, here division of a complex number is again a complex number. Now, this is z1 is equal to a plus ib divided by z2 is equal to c plus id. So, for division of a complex number, we have to rationalize the denominator. Just multiply both numerator and denominator by the conjugate of the denominator, c minus id divided by c minus id. Multiply both numerator and denominator by c minus id. Now, ordinary, just as that of the previous multiplication of complex number, a into c is ac minus a into d into I, again plus b into c, bc into I, minus into plus minus, I into I is I square, b d into I square, divided by in the denominator, c into c is c square, plus into minus minus, I into I is I square d square. Since we know I square is equal to minus 1, substitute here. So, this is equal to a into c minus ad into I as it is, plus bc into I as it is, minus I square is minus 1, minus 1 into minus 1 becomes plus bd divided by in the denominator c square, I square is minus 1, minus into minus plus d square. So, this can be written as, right here, just equate the real parts, ac plus bd, ac plus bd, again, and imaginary part plus I into bc, take positive bc minus ad, bc minus ad divided by root of c square plus d square. Now, term by term divide it. So, this is equal to ac plus bd divided by c square plus d square plus bc minus ad divided by c square plus d square into I. This is again of the form x plus iy. So, this is called the division of a complex number. See, just rationalize the denominator and multiply, you will get a complex number of the form x plus iy. This is how we are going to divide a complex number. Okay, just rationalizing the denominator, that's it. Hope you got an idea regarding addition of a complex number, subtraction of a complex number, multiplication of a complex number, as well as the division of a complex number. Now, let us take a few problems based on this. Now, let us come to this problem. These are very important problem for 3 marks or may expect for 5 marks. Reduce the given complex number in the form a plus ib or x plus iy. Reduce the given complex number in the form a plus ib or x plus ib. So, this is nothing but the division of a complex number. Division of a complex number is carried by rationalizing the denominator. What is given equation? So, I will write the given equation, 1 plus I divided by 1 minus I. Rationalize the denominator. 1 plus I divided by 1 minus I. Multiply both numerator and denominator by 1 plus I by 1 plus I. Rationalizing the denominator. Now just multiply it. So the numerator is of the form 1 plus I whole square divided by, in the denominator 1 into 1 is 1 square minus I into I is I square. Now you observe carefully, the numerator is of the form a plus b whole square, a square 1 square plus b square I square plus 2ab 2 into 1 into I divided by 1 square is 1 minus I square. Since I square is equal to minus 1, substitute here 1 square is 1, I square is equal to minus 1. If you want, you can write one more step, 1 plus I square plus 2I divided by 1 minus I square. Now I square is equal to minus 1, this is minus 1, plus 2 into 1 into I is 2I divided by 1. I square is minus into minus plus 1. Minus 1 plus 1 gets cancelled. 2I divided by 2, this is equal to 2 gets cancelled I. So this can also be written as 0 plus I. So therefore the complex number 1 plus I by 1 minus I can also be written as 0 plus I, which is of the form a plus ib, where the real part is 0 and the imaginary part is 1. So the given complex number is of the form 0 plus I, where real part is 0 and imaginary part is 1. That's it. Hope you followed. Let us come to the next concept, properties of complex number. So properties, identity property, that is additive. So if you add z plus 0 is equal to 0 plus 0, you will get 0, where z is not equal to 0, which is nothing but a complex number. So the additive property is just add. If you add 0 to a complex number, z plus 0 is equal to 0 plus 0, 0 plus z, that is also equal to z, for all z not equal to 0, which is again a complex number. So multiplicative property. So for example, for additive properties, 1 plus 0 is an example for additive property, whereas multiplicative properties, 1 into z is equal to z into 1 is equal to z. So 0 plus I into z or 0 plus z is equal to z, 1 into z or z into 1 is equal to z itself is called the multiplicative property of a complex number. Now let us come to the inverse property. Very important concept, this inverse property of a complex number. For a very complex number z, there exists some minus z belongs to the set of complex number such that z plus minus z is equal to minus z plus z is equal to 0, where minus z is called the additive inverse of the complex number z. Very important. So for any complex number z, there exists some integer minus z. There exists some minus z belongs to the set of complex number such that z plus of minus z or minus z plus z is equal to 0, where this minus z is called the additive inverse of the given complex number z. Now for a very complex number z except 0, there exists 1 by z belongs to the set of complex numbers such that z into 1 by z is equal to 1 by z into z is equal to 1, then 1 by z is called the multiplicative inverse of the complex number. So the additive inverse is minus z and the multiplicative inverse is 1 by z for a complex number. So for a multiplicative inverse, there exists a complex number z, and also 1 over z belongs to the set of complex numbers such that z into 1 by z or 1 by z into z is equal to 1 is called the multiplicative inverse. 1 by z is called the multiplicative inverse of a complex number z. Okay, these are regarding the inverse property of a complex number, additive and multiplicative inverse. Now let us come to the next concept, that is commutative property. Now what is commutative property? If z1 and z2 are the two complex numbers, that z1 plus z2 is also equal to z2 plus z1. Multiplication of commutative properties, z1 into z2 is also equal to z2 into z1. That is, for any two complex numbers, z1 plus z2 is also equal to z2 plus z1. And similarly, z1 into z2 is also equal to z2 into z1. That is called commutative property. So you might have been studied a star b is equal to b star a. Here, suppose if a and b are any two complex number, if you take z1 plus z2, addition, z1 plus z2 is also equal to z2 plus z1 in case of a complex number. Similarly, Z1 into Z2 is also equal to Z2 into Z1. These are called the commutative property with respect to addition and the multiplication of a complex number. Now let us come to the distributive property. For a very complex number Z1, Z2 and Z3, Z1 into Z2 plus Z3 is also equal to Z1 into Z2 plus Z1 into Z3. For any three complex numbers Z1, Z2 and Z3, Z1 into Z2 plus Z3 is also equal to Z1 into Z2 plus Z1 into Z3. Now, write distributive property. Just if Z for any three complex numbers Z1, Z2 and Z3, Z1 plus Z2 into Z3 is also equal to Z1 into Z3 plus Z2 into Z3. So, this is a right distributive property of a complex number. Now, modulus of a complex number. Suppose if Z is equal to A plus IB is a complex number, then the modulus of this complex number Z bar mod Z is given by root of A square plus B square. So, if A plus IB is a complex number, then the modulus of this complex number is mod Z. Length of this complex number is given by root of A square plus B square, the modulus. Suppose if X plus IY is a complex number, then the modulus of this complex number is given by root of X square plus Y square. That is real part and imaginary part. Just square root of real part and imaginary part will give the modulus of the complex number. Now, suppose if A plus IB and C plus ID are two complex numbers, if A plus IB is equal to C plus ID, then if and only if real part and imaginary parts are equal separately, if the real part A plus IB is equal to C plus ID, that means equality of complex number. If A and C are equal, if these two are equal separately and imaginary parts are equal separately, then they are called as the equal if and only if they are equal complex numbers. So, if A is equal to C and B is equal to D, then they are called as the equality of a complex number. The complex numbers are said to be equal. So, for equality of complex number, if real parts and imaginary parts are equal separately, then they are called as equality of a complex number. Let us consider a complex number. For example, A plus IB is equal to 4 plus 3i, where A is equal to 4 and B is equal to 3. If A plus IB is equal to 0 plus 0i, A is equal to 0 and B is equal to 0, these two are not equal. These two complex numbers, Z1 is not equal to Z2. Okay, because first complex number is 4 plus 3i, second complex number is 0 plus 0i, they are not equal, therefore they are not equal. So, now let us take one more example. If Z1 is equal to 2 plus 3i, another complex number Z2 is equal to 2 plus 3i, then these two complex numbers are equal. Z1 is equal to Z2. Okay, right. Now, let us come to the next concept. Let the properties of complex numbers. In that, let's see the set of complex numbers, then the closure property. For a very complex number Z1 and Z2, Z1 plus Z2 belongs to the set of complex number, that is addition. Z1 plus Z2 belongs to the complex numbers, then Z1 and Z2 belongs to the set of complex number, then Z1 plus Z2 is said to be under closed. So, the closure property existence of closure property. So, that is for any two complex numbers Z1 and Z2, if Z1 plus Z2 belongs to the set of complex number, then we are going to say closure law is verified, closure property is verified. Next, associative property. For any three complex numbers Z1, Z2 and Z3, if Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3, that is associative property with respect to addition. For any three complex numbers Z1, Z2 and Z3, Z1 plus Z2 plus Z3 is also equal to Z1 plus Z2 plus Z3, that is associative property with respect to addition. Or with respect to multiplication, Z1 into Z2 into Z3 is also equal to Z1 into Z2 into Z3. This is a associative property with respect to the multiplication of a complex number. So, for any complex number Z, 0 plus 0 is the additive identity of a complex number. Now, let us come to the next problem. Write the real and imaginary part of the following complex numbers. Very simple concept. We have to write the real and imaginary part. What is to write the real part? So, what is the given equation? 3 plus 4i is of the form x plus iy. The real part is 3 and the imaginary part of the complex number is coefficient of I, that is 5 is the imaginary part. So, the real part is 3 and imaginary part is 5. Now, come to this. What is the given equation? 3i. So, the given equation 3i can be written as 0 plus 3i. This is of the form x plus I into y, x is equal to 0 and y is equal to 3. So, the real part is 0 and the imaginary part is 3. Imaginary part is 3. So, let us express this 3i in the form x plus iy. 0 plus 3i is nothing but 3i itself. So, the equation 0 plus 3i is of the form x plus iy, where x is equal to 0, y is equal to 3. Real part is 0, imaginary part is 3. Now, let us come to the third one. The given complex number 6 can be written as 6 plus 0 into I. This is of the form x plus I into y. What is x? X is equal to 6 and y is equal to 0. So, the real part of this complex number is 6 and the imaginary part of this complex number is 0. The real part is 6 and imaginary part is 0. This is how we are going to write. This is very simple for 1 marker question. Okay. Now, let us come to the next one. Express the following in the form of a plus ib. Now, let us come to the next set of problems. This is very important type of problems. You may expect one question for 3 marks. Now, if z1 is equal to 2 plus 3i, z2 is equal to 1 minus i, find z1 and z2, z1 minus z2, addition and subtraction. Now, let us come to the first one. I'll take first one, z1 plus z2. z1 is 2 plus 3i plus 1 minus i. Just add the real parts, 2 plus 1 plus 3i minus i. So, 2 plus 1 is 3 plus 3 minus 1 is 2i. So, 3 plus 2i is the complex number. This is of the form a plus ib, where the real part is 3 and imaginary part is 2. Now, come to the second one, z1 minus z2. What is z1? 2 plus 3i minus z2. z2 is equal to 1 minus i. Multiply this by negative sign. Minus 1 minus into minus plus. So, add this 2 minus 1 plus 3i plus i. 2 minus 1 is 1. 3i plus i is 4i. So, 1 plus 4i is z1 minus z2. Again, this is of the form a plus ib is of the form a plus ib, where a is equal to 1, b is equal to 4. Suppose if they ask to write the conjugate means 1 minus 4i. For this, the conjugate is 3 minus 2i. That's it. Okay. Now, let us take next problem. If z is equal to 2 plus 3i, find z bar plus z and z bar minus z. So, what is given here? Z is equal to given 2 plus 3i. So, we know z bar is nothing but the conjugate. Conjugate of this is 2 minus 3i. The conjugate of z. Now, find out first one. What is the first one is z bar plus z. What is z bar? 2 minus 3i plus z is equal to 2 plus 3i. Just here minus 3i plus 3i gets cancelled. 2 plus 2 is 4. So, this can plus 4 plus 0 into i. Again, this is of the form a plus I into b, a complex number. Now, the second one. What is the second part? Second part is z bar minus z. What is z bar? Z bar is equal to 2 minus 3i minus z. Z is equal to 2 plus 3i. Just multiply by negative sign. If you multiply by minus, this becomes minus 2, minus into plus minus 3i. Cancel the terms which gets cancelled. So, here plus 2 minus 2 gets cancelled. Minus 3 is minus 6i. This can bring us 0 minus 6i. Again, this is of the form a plus ib. This can also be written as 0 plus minus 6 into I. So, this is of the form a plus ib. That's it. This is how we are going to add or subtract a complex number. Now, let us take a similar type problem. Now, evaluate 7 plus 3i divided by 52. Okay. So, very simple. This is 1 mark question. Evaluate z 7 plus 3i divided by 52. So, nothing given. What is given here? 7 plus 3i divided by 52. Just term by term division. That's it. 7 by 52 plus 3 by 52 into I. That's it. If it is possible to divide, divide it. So, again this is of the form a plus I into b, where a is equal to 7 by 52 plus b is that 3 divided by 52. Okay, now let us come to the next problem. Evaluate 1 plus I into 4 minus 3I into 1 minus I. Just you can multiply first, second and multiply with the third, or just multiply first and last and simplify. So let us take this 1 plus I into 1 minus I into 4 minus 3I. Simplify these two. So this is of the form A plus B into A minus B, the conjugate you can write. So this is the given equation. 1 into 1 is 1 minus I square into 4 minus 3I. 1 I square, since I square is equal to minus 1, this becomes y minus into minus plus 3I. So 1 plus 1 is 2 into 4 minus 3I. Multiply this. 2 into 4 is 8, 3 2 is 6I. 8 minus 6I is the required answer. That's it. Okay. Let us take one more problem, the last problem in this. Last problem. Now let us consider one more question. 1 plus 2I divided by 3 minus 4I. So this is the problem given. So we have to write the conjugate of this. Conjugate. Now what is given? 1 plus 2I divided by 3 minus 4I. Rationalize the denominator. That's it. So this is 1 plus 2I divided by 3 minus 4I. Multiply and divide by 3 plus 4I divided by 3 plus 4I. Multiply it. 1 into 3 is 3. 1 into 4 is 4I. Again 2 into 3 is 6I. Plus 2 4s are 8 I square divided by 3 3s are 9 minus 4 4s are 16 I into I is I square. Since I square is equal to minus 1, so this can be written as 3. 4 plus 6 is 10I. I square is minus 1. This becomes minus I divided by 9 plus 16. What is this equal to? 8 minus 3 minus 8. 3 minus 8 is minus 5 plus 10 into I divided by 25. This can also be written as term by term division, or you can take the common factor here. 5 is the common factor, minus 1 plus 2I divided by 25. You can divide from 5. 5 5s gets cancelled. So what is left over is minus 1 by 5 plus 2 by 5 into I. So what is the answer you obtained here? Minus 1 by 5 plus 2 by 5 into I. What is required to find? The conjugate. The conjugate for this is the conjugate. Therefore, the conjugate for this is minus 1 by 5 as it is, minus 2 by 5 into I is the conjugate. So if they ask to find the real and imaginary part, real part is minus 1 by 5, imaginary part is 2 by 5. Real and imaginary part for a conjugate is, real part minus 1 by 5, imaginary part is minus 2 by 5. This is how we are going to solve. So these are all regarding the addition, subtraction, multiplication and division of a complex number is again a complex number. Okay. So that's all regarding today's sessions. Hope you followed regarding the complex numbers. Now in the next session we will have a different concept. So thank you very much.